Good afternoon. So I am the Global Sustainability Director for Kimberly-Clark for Energy Solutions. What does that mean? Okay. We in Kimberly-Clark have organized water and waste and energy into a group that solicits both input from our business units that make our many products and also provides governance standards and controls across the world globally for Kimberly-Clark for the conservation of those natural resources. So for me, with energy, I'm tied directly to our climate change impact group. We have a goal to reduce our carbon footprint by 5% by 2015. The chief lever inside of that work is to conserve energy and provide less of the consumption that it takes for our products to be made globally. So this is my chance to introduce you to what is becoming a game-changing opportunity for Kimberly-Clark, both from the standpoint of climate change impact, but more importantly from the standpoint of cost transformation and margin protection, as well as the ability to engage our employees in the effort around conservation. We call it lean energy. That's not a misspelling. It rose out of our Latin American operation along with some collaboration with managing what we measure through operations analytics in North America. We blended it together into a process that embeds energy management into our manufacturing system, into our lean manufacturing system. So it's operational analytics, bringing delivery to the bottom line for both sustainability, for cost, and for energy conservation. So what's the challenge for our business? We make many products. We hope you love them and you have them in your homes. In fact, I just went out to the internet. Believe it or not, we are in 175 different countries with our products, and more than a quarter of the world's population uses Kleenex and Huggies diapers and many of the products that you see there, Andrex in the UK, Scott Tissue. We make those in more than 50 different countries around the world. And the big deal for us is that energy costs for that enterprise globally with 110 sites is approaching $1 billion spend, and we're a $25 billion company, okay? $1 billion spend at 110 sites. You don't have to do much math to realize if you just cut 1% off of that, it's a very big deal. We're talking millions of dollars for improvement. And much of our traditional approach to energy conservation has been through energy assessment and structural change. So if you compare sites, which we've been doing since the 1980s, in terms of energy performance, we will compare a site, we will develop a benchmark for the best-in-class sites, we will compare the structural machines and assets they have and energy delivery systems, and we will make recommendations to the best practices, and we will implement lighting improvements, variable speed drives, all of the normal structural improvement change that many of you probably do within your organizations, okay? But what we found is that leaves about half the opportunity still on the table because it doesn't address how the energy is used in that operation, and it doesn't engage our employees to help you deliver that. Our goal is to try to harvest an additional amount that we now believe with full employee engagement can be about a $50 million opportunity globally that up till now has been really untapped. So I want to tell you about the challenge. I want to tell you about how we came up with that number. It's a number that's gathered attention within Kimberly-Clark. I can tell you our CEO is very interested in harvesting that amount of money globally for us. So what's the opportunity? Well, first, it's figure out how to manage energy at the point of cause. So operational analytics, applying it to a machine envelope or an asset envelope, very important because an operator currently can't tell how much energy he's using to make the product. In fact, he's rewarded on those things, Sal, that you talked about. Quality, safety, productivity, the cost of the product. We have all of those metrics neatly aligned within our operating management system in Lean. He's got a dashboard for that. If he has a quality problem in the product and he can address it by turning up the heat, he does that and gets stroked for preserving OEE, right? He minimized the chance of delay, he optimized productivity. Really, the price tag for that energy to do that doesn't come till the end of the month with the bill. The financial analysts at the mill, the mill manager, the operations director, the VP of product supply, they all understand the problem and they all understand the differences in performance between the mills, but we don't have a way to translate that down to the floor. So getting it to point of use, critically important. Another one is visualize overconsumption. So we've done a lot of work to figure out how much energy we should use when we make a package of bathroom tissue or a carton of Kleenex. We can divide it in spreadsheets down to the ton or the minute by minute use of energy within a given process. We don't have any tools to make that information available at the floor to our operators, to our teams who are managing it where the pedal hits the metal. Third, we don't trigger action. So what do you do if you are using more than the amount of energy you should be using? You don't even know you've got a problem. There's no problem consciousness there because we don't have a way to show target versus actual. So first rule of lean, all work is highly specified. We haven't specified any work at that floor level that lets the operator know he's got to treat an abnormal condition for energy use with some action, okay? And then finally, our reward systems, as we just talked about, you can cover a problem with energy. There's no negative. In fact, many times there's a positive influence on that situation to thank him for preserving OEE or other attributes without a consideration, for that energy cost. And for us, in a very energy-intensive industry, we spend about 30% of our cost of manufacturing in energy. So I'd ask you, just from a problem consciousness, do you even know, how much you spend if you're a consumer products company or you have clients that are CPGs? Do they even really know how much they're spending, in energy as a component of their cost of manufacturing? So our attempt here is to create the idea of energy per box of Kleenex as a raw material into the product production itself so that we can start to manage what we can measure there and use operational analytics to do so. So why is it such a challenge? I've already gone over a couple of them. The real-time tools just don't exist to understand that there's a problem. So perfect analogy, how fast would you drive? This is a BMW speedometer, so I think it's going 240. I don't know anybody know what that is in miles per hour? That's kilometers, I'm quite sure. All right? So they're moving pretty fast. Yeah, over the speed limit. So how fast would you drive if you had no speedometer? Right? It's part of a system that keeps us accountable to drive safely, right? Standards don't exist to trigger action. I talked a little bit about that. We have benchmarks that we use as managers. We don't translate that down to the floor. So if you don't have speed limit signs on your roads and you don't have a speedometer and you combine those two, you're flying blind. You can't manage what you're not measuring, right? And the standards may not exist for you to even understand how fast you should drive if you have a speedometer. Third piece, we don't create experiences which change the belief that energy is a value within our operator's mindset. So we have a belief in Kimberly-Clark that in order to change your culture, you've got to create experiences that change your people's beliefs, right? Experiences like rewarding them for doing the right thing. Experiencing them like bringing out the importance of that energy cost in their minds visibly through visual management, which is a lot of what we're going to talk about with dashboards and OA, but more importantly, through the recognition that they're achieving their planned amount. We have a nice friendly reminder of that, right? If we don't go the right speed limit, we reinforce those standards many times through the negatives, but we try to talk to our kids, right, about driving safely because it keeps them healthy. There are a lot of impacts to your insurance costs, to points on your license, to having the freedom to drive where you want to drive, and not to mention the fact that tickets now cost you a few $100s rather than when I was a kid, maybe 50 or 60 bucks. So you combine those three things and you've built a system that reinforces the importance, in this case, of driving safely through visual management, right? Through an accountability process over on the right-hand side, and having the standards present. So you have a constant system of engagement between your speedometer, understanding that standard. In the past in Kimberly-Clark, this is a template for one mill in Columbia where we understand the energy inputs to the left, both thermal and electrical, our production to the right that I've covered up there for confidentiality reasons, and we understand the consumption in BTUs per metric ton. And down at the bottom here, you'll notice the overconsumption electrically at this facility, 19%, thermal overconsumption, 5.5%. So what? Right? How do we approach that? We're going to put some energy efficient lighting in. We're going to insulate some things. Our data suggests that we only achieve about half of the savings. Since 2005, we've achieved about $46 million in savings through structural change. One plant that's done lean energy so far has improved, that's 5% of the billion. One plant that's implemented lean energy so far has saved 5% of its energy with almost no capital improvements to structure. It's all behavioral in how they operate the equipment. So the solve for us is to try to attempt to do that on a global scale across our 110 sites. So creating visual management at the asset level, that first piece, that importance speedometer with target actual understanding, we're going to do that by building dashboards with real-time energy intensity. And more important to us, we have 130 different codes of facial products around the world. We need to understand how much energy it takes when you're making that grade on your specific asset. So bringing that standard to a point where the operator, the person on the floor at that machine, understands that's the planned amount of energy he should be using. Here's the amount that he's actually using. Very, very important in changing his mindset if he believes in the benchmark or the goal. Comparing a guy in South America to a guy in Europe who's under different standards, maybe they have cogeneration in their facility, very, very difficult to get him to take action on a day-by-day basis because he can discount the differences between his process and that process. Having a target that they help pick that improves them continuously based on having that real-time intensity at his face, really, in front of his whole team, helps motivate him to take that step. Next, and this is very important, integrating the dashboard, the OA dashboard, into the operating system for accountability. We have a lot of dashboards in Kimberly-Clark. We've employed several of the vendors in this room to help us in many ways with controls and automation and dashboards that are used by engineers. We predict and prevent failures on our equipment with them. We just don't do a really good job making the overconsumption of energy, in this case, in this application, an abnormal red condition that triggers action. So you have to take your operating system and your operations leadership, and you've got to make a change to the standards that if overconsumption exists from those dashboards, that you're going to take action just like you're wasting fiber, just like you're throwing away part of your raw materials, because you are, right? And then secondly, designing rewards to stroke the right conservation behavior. So making energy have equal footing with fiber, that's a good example. You can relate to how much tree fiber there would be in Kleenex. Having an equal weight in the dashboard says it's equally important to be green for your fiber yield as your energy yield. And stroking a team, a crew, a resource for being green through recognition, both formal recognition, informal recognition, affirmation that that crew is the best crew. These tools allow you to do that and parse the information for crew-to-crew performance, for individual shift performance. It gives you great power to do so. And then the third piece, and this is most important, is the mindset and capability training that must exist for a lean transformation of the mind. And so what we did in that same facility in El Salvador is we got out the facility's utility bill, and we got one of the operators in the plant to offer up his home utility bill, and we showed them that they're paying for the same fuel oil and natural gas and electricity, just with a lot more zeros, right, on the facility utility bill. Then we color-coded the fuel streams coming into the mill, natural gas, fuel oil, electricity, and color-coded it right up to the machine, right? So you can see the impact on your machine, see where it crosses the fence into a tank, see where it's used in the boiler, that steam comes to your machine, all of it's painted orange, and then in your dashboard, fuel oil overconsumption is read out in gallons per unit, gallons per ton that we overconsumed with a cost of that impact. So you're making it real and personal to the operator, and you're helping them believe they can have a stake in running your business. They can have a stake in making your business successful. So compelling value of energy per ton is important. Making it personal is almost critical to them doing the right thing when no one's looking. It's making them want to do the right thing when nobody's looking, right? So what's required in a global design standard? First, we divided our machines, we call them assets in Kimberly-Clark, into 7 different types. So we might have a personal care asset that makes diapers, Huggies diapers. We have a different asset that makes tissue for facial tissue and bath tissue. We have converting lines that we make rolled bathroom tissue with, different from interfolded facial tissue. We defined those asset types, and we created a very simple block diagram, looks like a control volume if you're so inclined, around that asset with all of the energy inputs into that process. Simple dashboard approach. So this isn't the actual dashboard, but it's very similar to this, and it would have your planned amount of energy and your actual amount of energy in each of these that are relevant to the operator. So he understands steam flowing to the Yankee dryer. This might even be color-coded again to the pipes that feed the Yankee dryer with steam, and the same for each one. And then as the process is managed, making changes to the process, for instance, the gas used to dry in the hoods that would dry the Kleenex would not only turn those components red to the planned amount if it goes over the planned amount, but it would also, if it outweighs all the good that you might be doing in these other energy areas, it might turn the overall energy per ton red for the entire tissue machine asset, the entire machine. That is what will trigger the action within their lean management system to say, wow, you had a quality problem, you covered it with energy. That's okay for exactly 2 hours until our escalation process makes us call maintenance, call the engineers, solve that problem, right? So it triggers that problem-solving event by creating a red condition somewhere else if you're only solving the immediate cause, not the root cause. So these dashboards have to be real time. It's got to be quantified with a planned amount versus the target amount. And for us, we found from the mindset of our people that it had to be product specific because, again, they will discount if you just say tissue and one tissue machine is making really heavy 2-ply bathroom tissue basis weight and another machine's making a real lightweight tissue. They'll discount the target, discount the benchmark, and they won't have a compelling interest in helping you because they don't believe the target's even achievable, right? So it's around having contextual information built into the system. So how did this unlock value creation for us? Well, first of all, it creates a really motivated understanding of the impact of changing a process setting. So I was very interested in what you said about decoupling operators or operator skill level, because we see the same thing. The skill level of our operators and the impact on labor cost of moving to places where labor is less expensive and perhaps less trained as they come into our facility necessitates us to understanding how they will react to a problem, but not being able to diagnose the problem themselves. They need that help to be able to understand that there's a problem that exists. So making it problem specific and having an instant cost understanding. We've put dashboards up that say, an hour of waste is worth, $1,000. But having it show up in the dashboard that the waste you're having right now causing this to be red is costing you $1,000 an hour and $200,000 for the year, that will motivate action instantly among that team and their leader, right? And then the tools that a good operational analytics solution can provide will allow the operator to actually drill down into the meters that support that dashboard and look at the trends of energy use there and give them not just data, but information that helps them solve the problem. We call that Kaizen or continuous improvement in a lean manufacturing process, right? But really what it is enabling the operator to stay on the problem, and he might bring other support when he escalates, but they don't hand the problem off. They stay in the room. They are providing the data from the dashboards to the engineers, to the maintenance guys who are solving it. The importance of keeping them with the problem is you don't want to take ownership away from the floor for the solution, but like you said, Sal, they don't necessarily have the skill set to be the maintenance guy, the engineer, and deduce when the problem's going to occur like they used to have. So the tool is very necessary to do that. The other thing is building crew talent through performance. Oh, now I've messed up here. Building crew talent through performance comparison and sharing. So these tools allow you to do crew-to-crew comparison that they believe in. They know the dashboards, they believe the dashboards. Difference in the past is we'll go gather the data and show the crews how they're performing. They don't know where it comes from. They'll discount it, won't necessarily believe it. You're driving this information real time. They can see how their crew performs, how their shift performs. More importantly, the red conditions, each one that they have gets logged. So you can see one crew might be having a lot of problems keeping their drying green. Another crew may not be having any problems. So now it drives you to go to the crew that's good and say, let's find out how you're managing it versus crew 2 and sharing those best practices. So it drives leadership to be able to tell where to drive the best practices. And then finally, having that accountability process make it a requirement to act when there is a red condition. So how do we stroke that energy is important? If we have a red condition, we're going to follow up and say, did we contain it to immediate cause? Did we solve the root cause if in a Pareto we continue to have that problem? What's needed for the visual management? Our solution comes through Schneider and their Ion-E and Ampla that they're now packaging into structureware. And so what you'll see is that the dashboards that we require flow from data analytics that has a plant operations model that is fed from both a power monitoring historian directly from the meters that are trended up and built into the dashboards as the numerator of energy per unit, and then a process historian that typically exists in our facilities now that captures all those other important manufacturing analytics like your production and the quality of your product, and in some cases even safety, Sal. It's very, very important. We put safety up on the top because we want to keep those operators alive in our mills. We build this all together from what is an existing base in each mill. So we go in and we do an assessment, and then we develop a model with the architecture that's necessary for that facility to layer on the final dashboard piece. And we can talk more about that, as we get to the panel. Our pilot site in El Salvador, we achieved an 8% reduction in greenhouse gas emissions from that one site. We have a global goal of 5% by 2015. They reduced 8% in 18 months at their site. Okay, so it's huge. They spend about $30 million a year. They've sustained savings of about $1.5 million with about $400,000 in US dollars invested. More importantly, we're now rolling this out in parallel across 3 different regions, so Middle East and Africa, Asia Pacific, starting in South Asia and then migrating in our North Asian facilities, and also Latin America, extending all the way down to Peru in 2013 and 14, with full plans to roll out globally across all facilities. And most recently, last week, we were selected by our CEO as the most impactful manufacturing implementation of lean globally. So this is a process where over 200 entries from around the world were provided. And I would tell you, this is very much just happening now in Kimberly-Clark. Typically, we would have to see this proven in several cultures in several ways, but because we're about 5 years down the road on our lean transformation, it just makes too much sense to slow down on. This is seen as low-hanging fruit that we should have been harvesting really all along. So that's it for me.